Okay, let's continue with objective 2. It says to using the unit circle, find the exact values of 6 trig functions of 0 degrees, 30 degrees, 45 degrees, and 60 degrees. To do this, let's complete this unit circle. And so it says unit circle, so we're assuming that, again, the radius is 1. Okay, so the radius is 1, and we're assuming now that we're putting points around the specific values, common values that you find on the unit circle. Okay, so let's start with 0 degrees or 0 radians. At this point, remember the radius is 1. The x value of this point is going to be 1. The y value is going to be 0. Okay, so if we were to say what is sine of, actually let's write it here, sine of 0 degrees. Remember, it's looking for the y value. What's the y value at 0 degrees? That's just y. So sine of 0 degrees is y. For the same reason, if I asked you cosine of 0 degrees, what's cosine of 0 degrees? Well, cosine is just x. Remember when you're working with the unit circle. And the x value is 1, so cosine of 0 degrees is 1. So we're going to complete the unit circle for all of these points. Let me just erase this so we can make some space. So now let's look at pi over 6 or 30 degrees and put a point there. Okay, so the x value at 30 degrees is root 3 over 2, and then the y value is 1/2. At 45 degrees, the x value is root 2 over 2, and the y value is also the same, root 2 over 2. At 60 degrees, or pi over 3, the x value is 1/2, the y value is root 3 over 2. At 90 degrees, the x value is at 0. The y value is at 1. Okay, going to 120 degrees or 2 pi over 3, we have negative 1/2 and root 3 over 2, because now we're on the negative x values on the left-hand side of the coordinate. At 3 pi over 4, we have negative root 2 over 2 and positive root 2 over 2. At 150 degrees or 5 pi over 6, you have negative root 3 over 2 and positive 1/2. Now at 180 or pi radians, the x value is going to be negative 1, the y value is 0. At 210 or 7 pi over 6, okay, now we're on the negative x values and negative y values. So we have negative root 3 over 2 and negative 1/2. At 5 pi over 4, 225 degrees, we have negative root 2 over 2 and root 2 over 2. Actually, they're both negative. At 4 pi over 3, we have negative 1/2 for the x and negative root 3 over 2 for y. At, I'm going to move down a bit. At 3 pi over 2, the x value is 0, y value is negative 1. 5 pi over 3, we have positive 1/2 and root 3 over 2. 7 pi over 4, you have positive root, forgot the negative sign here, almost forgot. This is a negative root 3 pi over 2 because we're on the y, the negative y values. Root 2 over 2 and negative root 2 over 2. And at 11 pi over 6, this is positive root 3 over 2 and negative 1/2. Okay, so somewhere on the unit circle, maybe on this side, write that x value is cosine of that angle, beta, we'll call it beta. Beta may be pi over 6, pi over 2. When it asks you what sine, you look for the y value, sine of theta. And then tangent, just remember that tangent is y over x for that angle. So let's do some practice with the following problems for these examples. We can use our unit circle to determine the following values. that's stated here. Okay, so if we look at sine of 5 pi over 6, this wants us to look at pi over 6, right? And then we're going to see, okay, what is the y coordinate of that angle? So let's look over to our unit circle that we just completed. And pi over 6 is located right here. And the y value, right, the y value of sine of pi over 6 is 1/2. And so sine of pi over 6 is equal to 1/2. So this is really easy when, right, you're able to use a unit circle. Okay, cosine 5 pi over 6, that's looking for, okay, what's the x value at 5 pi over 6? So let's look at the unit circle. 5 pi over 6, the x value, I don't know why I made that line there, but the x value is -√3/2. So this is just -√3/2. Let's skip over to 6. We'll come back to the other ones. Sine of 270 degrees is, let's look at 270. And if you look at 270, remember what sine again? That's a y coordinate. So sine of 270, the y coordinate is -1. So sine of 270 is just -1. Some of you may wonder, can you calculate that using your graphing calculator? And you certainly can. And we can go over how to use a calculator to check that during class. Okay, so let's look at tangent of, actually, let's look at cosecant of 570. So cosecant is the reciprocal of sine. And so that's here, cosecant of 570. We want to look at where the coordinate for y, 1 over y. The issue with 570 is that it's not on the unit circle. And this takes us back to getting that back into something that we can work with on the unit circle. And the way we did that was we subtracted 360 because that's a full unit circle, and 570 minus 360 is 210. And so we can say, okay, cosecant of 570 is the same thing as cosecant of 210 degrees because 570 and 210 are coterminal angles. And so cosecant of 210, let's look at where 210 is. 210 is located right here. And the corresponding y coordinate is -1/2. So if we do 1 over, or 1 divided by -1/2, we take 1 and multiply it by the reciprocal of the denominator, -2 over 1. There's 1 times -2 over 1 is just -2. Okay, so that's cosecant of 210. Secant of 11 pi over 6, secant is 1 over x because it's the reciprocal of cosine, and 11 pi over 6 is on the unit circle, so that's good. We don't have to do any work. So let's look at 1 where the x coordinate is. So 11 pi over 6 is right here. The x coordinate is √2 over 2. So I'm looking at the wrong one. I was like, there's something wrong with that. That's 7 pi over 4. We have to look at this one. It is 11 pi over 6 is this one. √3 over 2. And so 1 over x is going to be 1 divided by √3 over 2, which now we do 1 times the reciprocal of √3 over 2, which is 2 √3. And that's just 2 √3. So let's rationalize by multiplying by √3. And so this becomes 2 √3 over 3. Okay, now looking at tangent. Remember, tangent was y divided by x. Now, -3 pi is not on the unit circle. So let's get that back on the unit circle by finding the coterminal angle. And we can do that by adding 2 pi until it's a positive angle. So negative 3 pi over 2 pi is 1 pi, negative pi. And so that's still not on the unit circle. So we'll add another 2 pi, and that's pi. So its coterminal angle is tangent of pi. So let's look at where pi is on the unit circle. Pi is right there. And here's the x and the y coordinates. So we're going to take the y value, 0, divided by the x value, which is negative 1. And 0 divided by negative 1 is 0. Okay, so that's how we can use unit circles to determine the value of any trig functions that are on the unit circle.